What is connected graph? So before going to connected graph, first we see what is path. What is path? A path is known as walk and a circuit is known as closed walk. And simple path is called trail. So there are some terminology which you have to know. Let's suppose this is a graph. Okay. First you are going from A to B, B to C, C to F. This is what? This is a path from A to F. Okay. This is called simple path. Why? Because no edge is repeating. A simple path is a path whose edge is not repeated. And the length of path is 3. Why? Because there are 3 number of edges. Understood? Yes. And what is circuit? A circuit is a closed path whose starting and final point are same. So a path which is not a simple path.
So normal path means edges repeating. Simple path means no edges repeating.
Yes.
So circuit also no edges repeating, no?
What?
Circuit means it's a closed path, no? Like
Yes, yes. Circuit is
edges repeat.
circuit is closed path. Edge is not
So
repeated.
edges can't also repeat.
Uh, edges edges are also not repeated. Only vertices, initial and final vertices will be same. Okay. So what is connected graph? A graph is connected if there exists a path between every pair of vertices. Understood? For example, G is connected because every vertices are connected and making a path, right? So if you want to go from A to E, there is path. If you want to go from D to F, there is path. But in graph G2, there is no path between B to F or A to D because there is no edges connected with A to D, right? So G2 is not connected graph, G1 is connected graph.
Oh. All vertexes should be connected, then only it's connected.
Yes.
Yes. So no, is there a need to the proofs and all?
There are what?
These proofs and all for theorems.
I tell you. Noted? There is a simple path between every pair of distinct vertices of a connected undirected graph. Okay. So how will you prove this? What you have to prove? there is a simple path between every pair of distinct vertices of a connected undirected graph. Okay. So let U and B be two distinct vertices of the connected undirected graph. Yes, it is clear when a graph is connected. However, connected doesn't matter, but the path will exist, right?
Yeah.
Let's suppose you want a path from U and V. So you started from U and end with V. Is the sequence of path at least length E1, E2, right? The corresponding S sequence. This path of least length is simple, right? If they are not same, then this is not simple. Understood? E of I is equal to E of J. Then it is not simple.
So I understand. Path of least length means like the length means number of edges, no?
Yes. Length means what? Number of edges. If you want a path between U and V, so you have to start from U and end with V.
Yes.
If no any two edges are repeated, then you can say what? This is simple graph.
Oh.
Okay. So at least one path will exist from U and V. That's why this is called simple path.
Oh.
Okay.
Sir, one example can show. Sir, like is it used to solve the problem, the theorem?
It is not important to see. This is theorem only. Okay. Questions are not asked based on this. I will tell you how to ask the question.
So sir, what theorem is saying is that from U to V, it should be across the path.
No, it is saying that there exists a simple path from U to V. Okay. If
Yes.
there is a graph, that's it.
Oh.
Now see this. How many graphs? How many different graph are there? Three. H1, H2, and H3.
Yes.
Three different graph mean three component. The number of graph is called component. Okay. So how many components are there?
Three component.
Yes.
Sir, but how are the connected components like? They're not connected, no?
They are not connected. Okay.
Oh.
If you connect like this component will be one.
Yeah.
Okay. Okay. See, what is cut vertices?
vertices.
Cut edges, very important. Cut vertices means remove minimum number of vertices such that it divides into two components. Okay. And cut edges, remove,
Remove
yes,
number of
minimum number of edges such that it divides into two components. Understood?
yes,
Yes.
yes. How do we cut vertices? It just means in between we cut, no?
You noted this?
Yes, sir. I noted.
For example, this is a graph. You have to remove minimum number of vertices such that it divides into two parts. Suppose you remove this.
Hmm.
The graph becomes what? Right? It divides into three parts. So this is not,
Connected.
yes, BD will be connected. Yes. So this is what cut vertices. So B is cut vertices, C is cut vertices, and E is also cut vertices. So there are three cut vertices. Understood?
So, like, how do we understand which are cut vertices?
Okay. How do you understand which are cut vertices? Cut vertices means you have to remove minimum number of vertex such that it divides into two parts. The graph becomes split into two parts. So when you remove C, you will get graph like this. If you remove B, you will get what? A, DC, right? It is also divided into two parts. One is isolated graph and second is connected graph, right?
Yes.
When you remove E, removing E will get what?
Uh, Sir, FGH and ABCD would be.
Right, na?
Yes.
So you can also connect, sorry, you can also remove vertices. It is divided into components of graph, but minimum number of vertices is one. So you have three chance. You can remove B, D, or E.
So, because like we'll have to give trial and error and see like which are giving two graphs then.
You can see, always remove that vertices whose degree is maximum,
Oh,
right? Suppose so in the graph The degree of each maximum. When you remove this, check whether this is connected or disconnected. Now remove C. Now check by removing B and check by removing G.
So,
Okay. But when you remove G, you will get only one graph, right?
yes,
If it not works, then try for that vertex whose degree is next maximum. Okay.
oh, yes,
Yes. So why B? When you remove C, you will get this. When you remove B, you will get this. And when you remove E, you will get this.
yes, yes.
जब दूर लेके आना दूर है कहाँ पर हाँ दूर है दूर है कहाँ पर understood. And what is cut edges? Minimum number of edge you have to remove such that it divided into two parts. So what edge you can remove?
So C and D,
C and D, one edge.
A and
Any other example?
sir, A and
AB,
B.
AB
Yeah,
also.
yeah.
And what you can remove?
Others all are connected.
Yes. So this is the minimum number of edge. When you remove any one edge out
Mm.
of these two, the graph become disconnected.
Oh,
Okay.
yes,
Yes. See this. When you remove AB, you will get this. When you remove CE, you will get this. Okay. This is what
oh,
cut edge.
but it.
Done. One, two, three, four. What are cut vertices?
Oh, oh, okay. No cut right because it's connected. Like, one if we cut, then others are still connected.
Yes. When
So
you,
five,
yes. 1 and 3. So you have to remove one pair 1 3 or 2 4. The graph become disconnected because when you remove 1 3, you will get only two graph and both graph are isolated, right?
sir, but then it will be removing edges, no?
No, no, no. You
One,
uh, you have to disconnect two component. This is also component. This is isolated graph. Okay, this is graph 1 and graph 2. Okay, when you remove vertex 1 and 3,
So it's a vertex only one we can remove at a time.
No, not one. Minimum number of vertices you have to remove. This is not condition. If on removing only one vertex it does not work, you have to take, you have to remove two vertices together. If two vertices does not work, you have to remove three vertices together. Okay?
Yes.
Yes.
So in this case, even if we remove 1 and 3, 4 and 2 is still connected.
Yes, if you remove 1 and 3, why 4 and 2 connected? If you remove 1, it disconnect from 4 and 2. If you remove 3 disconnect from 2 and 4.
Oh,
You
yes,
will remove only 2 and 4.
yes.
Okay. Similarly, when you remove 2 and 4, you will get only 1 and 3.
Oh,
Understood?
yes,
And what are cut edges? When you remove 1, 2, it will not work. Right?
yes,
Then what will you do? You have to take pair of edges. You can remove 1, 2 and 4, 3.
yes,
Or 1, 4, 2, 3. When you remove 1, 2 and 4, 3, you will get only 1, 4 and 2, 3, right? Yes. Similarly, when you remove 1, 4 and 2, 3, you will get only 1, 2 and 4, 3, right?
yes.
Done.
Yes.
Now see what is proper subgraph. This is a graph. You know what is proper subset? This is a graph. You can find any graph which are subset of this. For example, this graph is coming from this original graph, right? This is also come from original graph. Even this is also a graph which comes from this graph. This is called proper subgraph. Understood? H3 is a null graph. And null graph is also a proper graph because null set is also a proper subset.
So there can be more subsets.
Yes, many possible subset. These are the only few cases.
Oh, Yes.
Done?
Yeah.
Okay. Now see counting path between vertices. See, A means what? If a graph, suppose you want to find the length, find the graph whose length is 1.
Mm.
You can see, you can connect from A to B in one step, right?
Yeah.
A to C in one step, and A to D is 0 because you cannot connect it directly with A to D, right?
Yeah.
B to A, this is symmetric,
Yeah.
right? B to B is 0. B to C is not connected. B to D is connected in one step, right? C to C, there is no loop. C to D is connected. D to D is not connected. That is for what? For length 1. If you are finding for length 2, you have to find what? A square. A square means A into A. And you know this is basic multiplication.
So I didn't understand. Like number of paths means like number of direct connections. Like there's no direct connection in it. That's right.
Yes. A2 means what? Here A square means what? You are connected from A to A in two steps. You can start from A and end with A in two steps. How? Two step means length 2. One from A to B and second from B to A. Understood? Yes. See, in A square, A to D is 2. It means what? You can go from A to D in two step. Two step means whose length is 2. First and second. Understood? You can go from A to C, but in not two step. In three steps. How? One, two, A to C. Three step. Wait. A square means what? Suppose you can go from C to C in two step. How? C to D and D to C. Understood? A3 means what? Number of path of length 3 from A to D is 0. You cannot go from A to D in three steps. Understood?
Sir, but they gave path of length 3 from A to D. I to D is 3.
Where?
0 they gave.
0. Yes, because you have to go from A to D in three walk. Three walk means covering three number of edges. Can you go?
No.
No. You
Sir,
can go.
then we can go now.
No.
Then
Fr-
once we can't.
From A to D. This is first step, second step. In two steps you can go. Right?
Sir, what is from C to D, D to B,
And
and
there
B
are
to C?
two paths from A to D. One from A to D, first step, and second from A to C. AC to AD. That's why here 2 is there.
No.
But if you try from A to D in three steps, means you have to cover three edges. You cannot go one, two,
Mm.
right? You can go into two steps, but you cannot go into three steps.
Oh,
Because when you go to C, you have to return with D in four steps. That's why here four is there.
oh,
Okay.
yes.
In three steps, you cannot cover.
Oh,
You can go from A to D, right?
yeah.
By eight ways. How? One, two, three, four, five, six, seven, eight. Right?
Yeah.
One, two, three, four, five, six, seven, eight. Understood?
Yes.
Yes. This is called number of path. You can note this.
So we'll be needing to find A1, A2, A3, A4. There
Uh,
are four edges.
yes, here in the question it was asked how many different path of length 1, 2, and 3. So you have to find it for A4. Okay.
Oh, Sir, there one term.
Yeah.
Last number of paths of length 4 from A to D is 8. Like, what does it 8 mean there?
8 means, okay, see.
8 different paths can be.
Number of path of length 4 from A to D is 8. So how many paths are there? This is number of paths. So there are 8 possible paths from A to D. First is what? A, B, A, C, D. This is first path. A, B, A, C, D. Understood?
Yeah.
Of 4, length 4. You can count. Length 4 means A to B, B to C, E, E. Right? Second chance is what? A to C, C to D, D to B.
Yeah. So only 2 possible paths.
No. 8 possible paths. You have to find. You cannot. It is very hard to find the path, but you can tell there are 8 possible paths are there. You can think and find more. How? A, C, A, right? This is one more possibility. A, C, A, C, A, B, D, right?
Yes.
This
Like
is,
that different combinations
yes.
we can be.
So there are different possibility, but maximum number of paths will be 8, whose length is 4. Yes. You can see one more. A, C, A, A, C, A, um, A, C, A.
Yes, I understood. Like
Understood,
that we
no?
don't need to.
Yes.
Yeah.
Now difference between connected subgraph and connected component. You know subgraph. Subgraph is a part of a original graph. Right? There are 3 different graphs, H1, H2, H3. These are 3 components. Right? Different components. But H1 and H4 are, H1 is original graph, H4 is subgraph of this. That's it. This is what? Components. How many components? 3 components. And this is what? Subgraph. Why subgraph? Because H4 is induced from H1. Understood?
So the first one is a connected component. The first figure.
Yes, there are 3 components. And this is subgraph. This is same proof as given above. Okay. there is a simple path between every pair of distinct vertices of a connected graph, connected and direct graph. So if there is any undirected graph, there is a simple path between any two vertices. Okay, this is simple proof.
Like there's always a simple path between two connected.
Same. This is same proof, the theorem. Understood? Now we will see Euler graph and